Hang on guys, I just turned on the other light. Howdy guys, welcome back to Cruiserman's Inventions and this free energy machine that Joe Marin gladly showed us, and he spent a lot of his money and his time and resources and everything else trying to show us this free energy machine. Now I'll explain what this is guys. This here is a pump motor out of a washing machine. I'll try and get a little bit of a close-up. There we go, that's perfect. Now as you can see, this motor here guys is out of my cordless drill. I just took my whole cordless drill apart and grabbed out the motor. And that's the DC. This is the rest of it. It had no variable speed in this trigger. That's why I didn't use that controller to variate the speed in this motor here. So it didn't have that one, it just had forward and reverse. But if it had a variable speed, I could have used that controller for sure. It's only the gearbox in those things, the planetary gearbox, that slows those motors down, these ones down inside a drill. Okay, so with them by themselves, as you saw, that was well capable of a 12 volt battery right there at 7 amp hours of producing well up to close to 8,000 RPMs just to this little washing machine pump motor. What I've used down here guys is wire joiners. This is the wire joiner. See if I can get a close-up of one for you guys. Here, this is what I'm talking about, one of those. And I've just taken it out. That's the metal thing inside it, see? So what I'm going to do guys is I've already spent close on 3 days aligning all of this up, trying to find all the bits and pieces, trying to get it all stuck and everything, and something actually happened to this guys. And it happened in the first video that I done of this, which is a bit of a shame. Look over here, I'll try and turn this around and I'll show you guys something. Remember in the first video how I showed you this? That is the problem. This coil is actually blowing. So what I'm going to do now guys is I'm going to race out, and I know where another washing machine is. I'm going to take this one off and I'm going to replace it with a whole nother one. And then this is a video just telling you about how far I am with this, because this is really like part 2 of this video, since I was telling you all about different motors and stuff. So over the last couple of days I've been building this box. And in this box is where this is going to fit. I also have like speaker inputs and stuff that I can put in the box. I also have 2 of these batteries. I also have a speed controller, a DC speed controller, which I showed you in my last video, which is 24 volts. I have to find a volume control, so I did. It's stuck in here. See how it has the 3 wires? This is what it looks like. So I'll chop this out. Down here, and then I'll drill a couple of holes and then, you know, chop a hole out in the box and put it in there. Wire up the 3 wires to the 3 wires that usually go to a throttle in the speed controller. And then I can variate the speed in the DC motor. And the output of what this one's going to give. Now I also got plugs and stuff like that. So in the back of these guys it's really interesting, because it shows you it has an N here, which is supposed to be negative, an E for earth, and an L for the line, which is your red. You see how they're coloured? That N is supposed to be black. But anyway, the colours come from the old wiring colour code diagram from... It's funny, they should have this still, but it's a way of determining which wire goes where, still, by the colours. Back when Thomas Edison was in power with the DC and all that, and Tesla was just getting his generators going, if you look in old houses behind light switches, you'll see the old wires still in there, black, red, and green. They were the DC wires, right? Color code. It doesn't really matter for alternating current. You can have them any which way, but you know, when you're wiring house stuff, it really does matter. There's certain lines that you got to watch out for, right? And they got to be in their proper order still. So that's why that's like that still. So, anyways, guys, getting back to that, I have this, and this here goes on the end of that. So this spins this up. Power comes out these two wires, comes straight into this unit here, and then you can start plugging up light bulbs like coil light bulbs, iridescent light bulbs. Apparently the tube light bulbs are the best to run, even if they're blowing. So I have more tests coming up, guys. I'm just showing you how far I've gotten with it, and now I've gone about 2 steps backwards because I got to change all this out. I got to wait for a whole nother day for the glue to set, and I already tried to push on through time barriers as much as I could to get this done for you guys, but oh boy, I got set back again because of when I start these projects, guys. Sometimes I'm working with already stuff that's around me, and some of the stuff's already broken. And it's a real head scratcher when you've got that on your hands as well, let alone having to build all this stuff. So stay tuned for part 3, guys. There's all sorts of things you could put on the box. Cigarette lighter pieces, and you know, there's the USB parts at the end of the cigarette lighters that could go on that. That could be fed off one of the 12-volt batteries. You know, you could have 2 separate lines for 2 different 12-volt outs. One of these going to 1, and the other one at 24 volts going to 2, just for, I don't know, extra optional power if you needed it. But anyway, the box is sort of getting done, and yeah, so I just got to go out now, go and grab a new one of these, stick it all back together. Yeah, it's costing me more than I thought. There goes my drill. Anyways, guys, hope you enjoyed that, and stay tuned for more. I will be back soon. Cool, guys. Cruiser Man out.